Hello, Alexa developers, and welcome to the Alexa Web API for GameStream. I have with me two co-presenters, Chris Subagio and Luis Valencia.
Hello.
Hey guys.
Hello.
Hey, Joe.
You are both engineers on the on within Alexa Games. What do you do exactly?
Sebastian, you want to go first?
Yeah, sure. I've been an engineer with Alexa Games since Alexa Games started. That's 3 years ago. Before that, I was with the Amazon Game Studios as a rendering engineer, as an AI engineer, as a designer, as all kinds of things. Before that, I was at Double Helix, which was the studio that Amazon acquired to produce that, the Amazon Game Studios. I've been in gaming since 1999 or so. Let's just pretend I was like 10 years old when that started. And I have a sort of strange careers that started in film, animation, special effects, and then turned into video game art and video game engineering. And now I don't do anything visual whatsoever. I work on Alexa, and I try to make it super entertaining to hear audio things. And then suddenly this year, we've added visuals back again. So long arc that got me here. Your
Very
turn,
cool.
Luis.
Thank you. Yeah. Basically, I started working here at Amazon, I want to say around 3 years ago. And actually, I started off as a skills developer on the Lantern team, which basically was focused mainly around that. And then now, fast forward 3 years later, I'm working on the ASK Games Tech team, which is basically focused on driving this web API for games.
Very cool.
Um, yeah, I mean, the only thing other than that prior to that is I had a lot of experience as a web developer before I joined Amazon.
So that's pretty awesome that you get to keep working on web development technologies.
Yeah, very cool. I'm on the other side now. I'm working on the actual tech instead of the development. Well, you always do both, but yeah.
Let's get into the meat of this content here. Um, so we've just gone over this, but I'll hand it off to you, Luis.
Thank you. So yeah, today, like Joe said, we're going to be talking about the Alexa Web API for games. So I want to start with like kind of like what is it in case people haven't heard about it, or maybe they heard a little bit about it but aren't quite sure what the Alexa Web API for games are. Basically, the Alexa Web API for games is a technology for building content on-screen devices on the Alexa platform, right? So we're augmenting the capabilities of Alexa with the power of the web. So if you're familiar with HTML, CSS, and JavaScript, you can now use these existing technologies to create rich gaming experience on the screen devices. And also because it's running on device, we're enabling on-device low latency processing. So basically, your experience will be running on the device in a web environment or sandbox.
Seems pretty
Uh,
cool.
yeah. So before we get into the meat of this, so I'm going to go in and start explaining some of the APIs around that it basically enable us to do this. Everything from launching an application to how communication works between a skill and an application running on device, and maybe some of the distinctions. And then I'll be showing a couple demos, and after that, I'll basically hand it off to Chris to talk about some more of the design aspects of the stuff. But yeah, so basically, like where we start is like, how do you launch it? Well, we have these new directives in on the skill that you can send down to device to basically start the application. So there's a couple things you need to know before you start using these directives. You need to have the HTML interface enabled, which will be available to you in the developer console. And then once you launch your skill on device, that initial request to invoke your skill will basically contain an indicator whether or not the HTML is supported on the device that it's running. And if it is, then basically you just send down this directive, which is the Alexa presentation.html start directive, where you can configure things like your session duration. Right now, the example that I have on the screen basically says you can set it to 90 seconds, but you can set it all the way up to 1800 seconds, which I think is 30 minutes. So you could just launch your application and have it run without interaction for 30 minutes. And you can include things as part of your requests, headers, and all nice security stuff. So basically, you just say, hey, this is the URI I want you to load. It's your HTML experience, and you send this down to the device, and then the device loads this in a website. Yeah. So now you're going to have there's two concerns here, right? You're going to have the application that is running on the device itself, which is a website, and the skill that you're invoking in Lambda, right? So once you start your experience by sending the directive down, you're going to need to initialize the Alexa components that basically allow you to interact with the different allow you to interact with the API. So you just we vend you an Alexa object that will be available on device that you can start coding against once you launch it. We also host this in a CDN, so if you want to develop on it while you're debugging, it's available to you. But you basically instantiate the new Alexa object. You provide the version that you want to fix to, and when the API is ready to go and has been initialized, you will receive an onReady message event. And then if for whatever reason it fails to initialize, you'll receive an onReady failed event. And so what that means is that if usually or most of the time it should be onReady, like 99.9% of the time should be onReady, and you will know that you're ready to start your interaction and ready to start your Alexa experience, right? If it fails, then you can basically react to it and say, okay, something failed. You can inform your customer and ask them to like relaunch the experience or provide an experience without some of that interaction.
Very cool.
Yeah, I feel like we're going kind of fast. Is there anything that we might need to pause for, Joe? Or
well, yeah. So if anyone has questions in chat at any time, of course, feel free to shout them out. We do have a comment here from Gold Zulu asking, "Is it in real time?"
Is it in real time?
Yeah, can you clarify that a bit, Gold Zulu? Is what in real time? But it's worth noting, just to be totally clear, this code here is what would be in your web app. That is grabbing that Alexa object from the runtime of the device, right?
Yep. Yeah. So I'm not sure what this person means by "is it in real time," but once the application starts, it's like running a website on the device in a sandbox environment. So it's about as real time as it can be. If they're referring to the device events, the device events are happening. You are getting those events straight from the device, and there's no cloud round trip or anything. Like, you're getting them as they happen.
I see. So Goldzulu actually clarified, the interaction between users Alexa and the backend web. So yes, they are device events, Goldzulu. So these events are local in that web app that's running in the sandbox.
Yeah. Okay, so let's talk a little bit more. That's actually a great segue into like how does the communication work?
Yeah.
So I guess the first part I want to highlight is you now have two places that you're running code. One of them is on the device, right, where you can react and have things happen in real time, and then you can still talk to your running skill. Your skill is in session at this point. So as part of the API, we provided a bridge called send message, and this basically allows you to send a message from the device to the skill. And you can put whatever you want in it. The payload can be anything. So like in this example, we have like an object that has some state, player, like a number of players, state, and like maybe some speech associated with it. This message will get sent to the skill, and when you receive it on the skill, you can see on the right that you're going to get this request come in, and it looks like a typical request with the exception that the type is now an HTML message request. And if you receive this request, you can see that your message is literally going to be in the message object.
Can you just send arbitrary sized payloads here, or are there any limits?
That's an excellent question. So the answer to that is you can send payloads as big as the current limit of the skill communication allows you to do.
Okay. Very cool.
Yeah. So yeah, nothing bigger. Go ahead.
ready to see a short little demo of one example?
Yeah. Can you set it up, Joe?
Yes.
So yeah, so what I'm going to show, what we're going to show right now is this is 2048. This is a skill that is now live. I think you can use it on. Thank you. You can go try this out right now. And basically, what I want to show here is that you can see that there's interaction events happening with the device directly, and the the state for this, I'm pretty sure, is being tracked on the skill. So each of these like events that you're interacting with could represent a send message to your skill where you're now basically keeping track of the state of the game, right? So that if the game were to like crash or something were to happen, or a person goes and does another interaction or something happens, you can restore the state from the skill, right? Because from the skill side, because you've been sending those messages up. So that's what I want to highlight with this.
So you could both have that real-time interaction on screen and then store that in your backend as well.
Yeah, basically you can start treating your skill as a backend for your game. But you are on the web. There's nothing restricting you from doing that. If you have different very specific requirements, you could be talking to your own service because again, you're on the web.
So Lord of Sound and Chat here, whom I know has done a number of different skills with Web API, is saying another huge advantage is you get advanced device information on the client side. So you can have voice input mode, push to talk, or wake word, and send it to the server. So you can change your skill behavior based on like the method of interaction there. Better game prompts, device, etc.
Yeah, no, that's a great call out. We talk a little bit about that later. But yes, there's a bunch of events that you can just like forward to the skill and react accordingly because you now have access to that. You could just react to that in real time in your web, but basically you have access to that and you can do whatever you want with it.
We have a question here from Yiddish Ninja. So he's saying, does the HTML app also get a unique user ID like the skill? So is it actually the same user ID as that same user using the skill in on a non-Web API compatible device?
So the question, I think, if I understood it, is there like something that is tracking the like a quote unquote like session on device differently from the skill? So maybe this will add some clarity to that question. Is the skill session or your skill session and the user ID and all that stuff is attributed and all handled on the skill side, which means that it's tightly coupled to the skill session. There's no extra information that you need to concern yourself with on the website as it pertains to a user ID or skill session. It's all skill side.
Now, having said that, if you did want to contact another service from your web page, you can use the same user ID. Like you can pass the user ID to yourself using one of those messages, right?
Absolutely.
Very
so
cool.
If you need it, you can forward it to yourself. Yeah.
Urban Blaster asks, "Dang, what do I use next? Web API or Skillflow Builder?" You could use both together, right?
Yeah, there's
nothing.
A prototype Skillflow Builder HTML extension out in the wild, and SFB does allow for extensions itself. And since these are since the interop between the skill and the HTML is just a bunch of directives and events, SFB already works with this.
Yeah, it looks like.
Yeah, and then actually, sorry, I wanted to add something to that. You can basically use whatever you want to build your web experience that is available to you. So any existing frameworks, any so like Skillflow Builder, Latexa, like, and then just regular like website stuff that is available to you, like Angular and stuff like that.
Cool. It looks like there's some fans of Howler.js, 3JS in Lord of Sound is a big fan of those too.
Yeah, shout out to both.
And Goldzul.
Yeah. Nice. Very cool.
So let's talk a bit more about the messages.
Yeah. So basically, so far we've talked about from device to skill. Obviously, you would expect there to be from skill to device. So this is the flip side of this. what this looks like is you basically send a directive called handle message, because you're going to be handling the message on the device. And in the message object, again, you can put whatever you want in there and then send it down to yourself. So on the left, or actually, I don't know if it's inverted for the viewers, but on my left, you can see the directive of the handle message that you're going to be sending down as part of your response. And then on the right, you can see the complementary code for how you would be reacting to that. And then the thing to note here is that the on message handler basically will receive all the messages that you send from skill to device. So this is just handling the particular case that I've outlined here, but any message that you send down will go into this function, and you basically handle it there and react accordingly.
So Lord of Sound is pointing out that there is that packet size limit. So that is the normal skill services limit in yeah. So just before you go in passing around massive states through this mechanism, be warned that that limit exists. Greg's asking, are there any benchmarks on common JS game engines on different devices?
We have a section on performance. We can talk about that then.
Okay, let's save that for then.
We'll defer that for later.
Ask that question again later.
So like I want to show a quick demo that highlights this opposite flow.
All right.
So this is Elfmeterschießen. It is a game that is actually available. You can play it now. Developed by a German games developer.
Wohin wirst du schießen? Rechts oben.
So in this interaction, you can't really. Well, I can't really see the bottom bar, but basically, there is a voice interaction happening, which is gonna land on the skill, and that as part of that interaction, the message is being sent down to basically kick the goal. And I think Elfmeterschießen stands for penalty shoot. So they're basically saying, Alexa, like kick to the right or something like that. I don't quite remember. And then that event, and then from the skill, that event is being sent down to the web, and then the web is reacting accordingly. So very cool.
I love the use in this skill of the Alexa open Elfmeterschießen in the background.
Yeah, offene.
Offene.
Yeah.
And also worth noting, that's all 3D.
Yeah, that is all 3D. It's very cool. This API. I actually really like this API. This is something we came up with, and actually I have to give kudos to Chris here. As we were figuring out what kind of experiences we were trying to enable on the platform, on the device. And one of the things that you'll see in a future demo in a little bit is we have integration for taking a transformer MP3, if anybody's familiar with APL transformers, or any MP3 that has Visime data. So I think that includes the poly MP3s and all that stuff. And we can actually go fetch it for you and demux it. And so what that means is we can separate the raw audio data from the Visime data and then give it back to you in order for you to do things like audio and text synchronization, or lip syncing potentially, and that kind of stuff.
Just for some clarification, what is Visime data?
You know what? Chris can probably explain that like 10 times better than I could. Chris, do you want to take that?
Yeah, sure. Visime stands for visible phoneme. So it is a stream of data that is time-stamped, that describes the shape of the mouth of the speaker in the audio at that time. So when you're doing TTS, that data sort of comes for free, right? If you generate the speech "Hello World," there's a h, e, a, u, r, sort of shapes that happen from that. And if you send yourself a TTS with a transformer, you get information for where each one of those points in the audio is. And then you can use that to drive an animation. You can use that to drive captioning. We'll see an example of that later.
Okay, great. So if you want to use this, and if you can't see the code, don't worry, we have documentation for this, but I wanted to just highlight how you would use this. You basically send the directive the way you normally would, but you also include this transformers object, and the transformers object is the same as you would expect if you've been using like APL or something like that. You basically provide what data you want to transform, and then that'll take your SSML and then turn it into this MP3. And so when you receive it on the device, you have the MP3 that you can then use. Then you could then pass through fetch and demux to extract the audio data and the vising data. And then so on the left is if you're using handle message to send messages from a device, and on the right is if you want to send it with your start directive.
Oh, cool. So you can have transformers in either case.
Yes.
Very neat.
Yeah. And so I also want to highlight the kind of like the part, or at least the part that I really enjoy from this API is you can basically now react to events that are happening on device. And so one of the developer pain points that we know they were running into is they were having a hard time reacting to device events as they were happening on the multimodal devices. And so what we're doing with this API, as you can see on the right, is we're giving programmatic access to the microphone to developers on this platform. And so what that means is that you can now have the device open the mic without waiting for an interaction from the developer or a voice interaction specifically, right? So like someone can tap on the screen and then you could open the mic, or you can open the mic if it makes sense to like now open the mic right at the end of an animation or something. I want to clarify, this doesn't mean that you're going to get the audio data. The audio data still goes through the skill. You don't have access to that, but you do have access to the events that are occurring on device when you open the mic. So you have access to programmatically cause it to open. You can react to if there's, for any reason, our API has an issue opening it. And then you can also react to when the microphone has been opened and when the microphone has been closed. So you can now do things like I've opened the mic, or the mic is open, I know about it, and I can duck audio, I can change the animation on the screen, I can like maybe display something on screen, change my game state, etc. The microphone is closed. Okay, let me bring the audio back up and stuff like that.
This seems really powerful for games. You don't even have any amount of lag between when sound stops or when an animation is completing and you want the customer's input.
Yeah, there's no round trip latency caused by going to the cloud and back. It's all the events you're getting real time from device.
Very cool.
Before we move on, actually,
yeah.
I did want to highlight one thing, and I think I kind of touched on it, but I didn't really like emphasize it. Is this allows you for games that don't fit into the mold of a conversational paradigm to break away from that paradigm, and I think that's the real like sauce here.
Ah, that's really well said.
Yeah.
Yeah, that relates back to.
Go ahead.
So that relates back to what Joshua was saying earlier in the Ticket to Ride stream. That one thing people don't realize you can do is not prompt your player immediately to do the next thing, right? You can play a bit of music to let them think things through, and then they can use the wake word to interrupt and break in. With the HTML stuff, that becomes even more obvious because you can keep audio playing in the background anyway. You can put a prompt up on screen to say, like, hey, when you're ready, do something. And you have the option of both pressing to talk and then tapping on the screen on an icon or the entire screen if you want to, as well as using the wake word.
And no need to break your background audio while you do it. You can duck it instead.
Yep.
Yeah. And then naturally, so the same way that you can react to those events, you can react to the speech events too, right? So if Alexa's talking and you need to know about it, then we will send you a non-speech started event, and then as soon as she stops talking, you can you will know about it and you can react to it accordingly.
Cool. We do have a couple of questions in here. Gold Zulu is asking, can we play Flappy Voice? Well, I mean, if someone makes it, you could.
Is that the one with the chicken where you have to make chicken noises to make the chicken advance on the screen?
No, but that sounds maybe along the same lines. Maybe better.
I think it is. I think that's an existing one, and but the answer is no, because you still don't get. I think Flappy Voice is based on like volume of input audio on the microphone, and that you still don't get, unfortunately.
Yeah.
I see.
But it is fun game if you guys haven't played it.
Shri is asking, can Alexa run completely from Snowball Edge? I actually don't really know very much about Snowball, so I don't know the answer to that one.
What would you want to run off of Snowball Edge? Bear in mind that the best location for your endpoint is co-located with the Alexa service itself, which in the US is always in US West.
And there is a tech doc.
Sorry, US East.
There's a tech doc somewhere. If maybe Greg or Mark could find it with where to locate your services depending on locales. So that would be best practices for the web API as well to serve from there.
Actually, no. So the web API will be slightly different, right? Because the web API, the data that you're going to feed the device is going to be fetched from the device. So you want to be as local as possible to the device. In which case, something like CloudFront makes sense.
All right. Okay.
There you go. Great. Is there? Joe? Do we want to step in for any questions, or is it demo time?
We can get to another demo, and as the questions come in, we can.
All right, cool. So this next demo is Ticket to Ride, and what it's going to be highlighting is going to be the fetch and demugs, the speech events, and the voice events. So this is going to be really good. So what you're going to see is you're going to see an open mic event without there having been an interaction from the user, and you should notice the audio duck and come back.
Start from here.
Alexa, Red got Denver to El Paso.
All right.
Oops, Denver and El Paso aren't connected. Remember, you can only connect one route on your turn.
Alexa, Red got San Francisco to Los
Hey
Angeles.
Joe, is this the video?
Do you want me to go back?
Making sure.
Back to the start?
Welcome back, adventurers.
Yeah.
Okay.
If you have any
not
questions
necessarily. Yeah, let's just
feedback
go
about
through a
Ticket
little
to
bit.
Ride, please see the card I just sent to the activity feed in your Alexa
The
app for
things that I want
details
to watch out
about
for,
how to
like I
get
said,
in
are
contact.
specifically the she
How
starts
many of
talking.
you will
I think
be
she's going to
playing
open the
today?
mic. Yeah, so
Right here.
how many players are you?
2.
No user interaction has happened
Ooh,
yet.
looks
the
like you have
mic
room
is
for
able to
one more.
open, and that is
Want me to
enabled through
join?
the request mic. And as the mic opens,
No.
you can see the audio. You can hear the audio duck, and then you can hear it
Aww,
come back once the
maybe
interaction.
next time.
So that's
Do you
what I
already
wanted.
know how to play
That's little
Ticket to
things like that.
Ride?
And then once the interaction happens, you
Yes.
can see that the text is syncing with
Great.
the Alexa speech,
Is the
and that
game
is
all
done
set
using
up and ready to
Transformers
go?
MP3,
Yes.
and with the Transformers MP3 data, by Zoom data.
And if you want to see more about Ticket to Ride and tabletop design, check out the video that we'll post on YouTube afterwards.
Yep.
And if you want to see more of the experience, play the game. It's pretty fun.
It actually is pretty fun. And then, the last thing I wanted to highlight is before I hand it off to Subagio is how do you know what you can do on device and that kind of stuff, specifically around the microphone. So as part of this API, we vend, as part of the Alexa object, we vend a capabilities object that basically lets you know some information about the device, right? Things like what is the display in physical width in pixels, so like you get an idea for how wide it is, how tall it is, and the shape, so round versus rectangular. You also get information about the microphone data, since it works differently across devices, right? If you're on a Fire TV Cube versus like an Echo Show, then you're going to want to know these differences so you can tailor your experience to the devices.
Now, question for you: is this the same viewport profile information you get as a part of any APL device as well? Like, is it in the viewports section of the request envelope?
You know what? That's an excellent question. I can't answer that with 100% certainty. Intuitively, I want to say no, but I would have to circle back on you on that. Unless
you do get some of that information. You could do get some of the same information on the skill side. Here we give it to you on the device side, so you don't have to set it to yourself.
I see. Okay, so this is a device side capabilities API.
Yeah. Now the important distinction here is that the physical width of the device in pixels is not necessarily what the HTML page will give you if you inspect the window's inner width and inner height. And that's because of device pixel ratio for anybody who's sort of web savvy out there. So we wanted to make sure we gave you like the legit physical size, unmodified by whatever your viewport headers are or whatever this is going on your HTML page.
Okay.
Yeah, that's an excellent call.
Yeah, that is a really good call out. So what would you recommend for developing and testing these experiences?
Oh, is that my turn now? Cool. Yeah, so in doing development for WebAPI so far, we found that working on your Mac or your PC and Google Chrome is definitely the way to go when you're working on your logic and you're working on your visuals, and you're not focusing on input from Alexa yet. Much faster iteration. The debugger makes a lot of sense. It's really comfortable, especially if you're a web developer. You're already familiar with all those tools. So that's like the place to start. You have to start your web app. And then once you're actually testing on Alexa, I recommend 3 different devices. The Echo Show 5 is the smallest screen, and it's small enough that you probably want a different layout. Like text is not going to be legible the same way. You're probably going to want to drop a couple of visual elements, make a couple of them larger. For the average layout, I take an Echo Show 8. That gives you the average size of a touchscreen Echo device. And then you'd also probably want to get a Fire TV. I recommend the Fire TV Cube 2nd generation. That will give you your all the way up to 4K output on the television. And I recommend that one specifically because that's actually our most powerful chipset. So that will be the top end of your performance on the Fire TV Cube.
Cool. And Lord of Sound is reiterating here. The Android debugger and Chrome DevTools on a Fire TV Cube or Stick is pretty great to use.
It is awesome. So yeah, we do have ADB access on Fire TVs, but not on Echo Show devices right now. So if you do find that you have some device-specific errors, it is significantly easier to track them on a Fire TV Cube.
Now, do you recommend using any? Is there like a polyfill library, or do you recommend taking some kind of approach like that for doing your on-computer creation of the web app?
Well, yes. Let's. I've got a slide coming up. I think I've already talked a little bit about that.
Oh, right. We'll move on then.
So this one's just a practical check-in. When you're developing, bear in mind that you're going to still be developing a skill as normal. You'll need the endpoint. You can add whatever you want to endpoint, like persistent storage and so on. The new stuff that you're going to be adding will be effectively web page. It can be static. There doesn't necessarily have to be anything dynamic on that web page because you have the skill backing it. And so dynamic information is going to come down from the skill, and you can persist data on the other side. So the static website is a good fit for something like just copying your entire website to an S3 bucket and then turning Cloudflare on, so that your customers get the fastest download speed possible. Optimization rules for your actual website to load as fast as possible, to operate as fast as possible, all match exactly the same stuff you expect from the web. Pack your JavaScript files into the least amount of files possible. Optimize your images so they're as small as possible. Bandwidth matters. A number of files matter. All that stuff super the same. And in fact, again, you can use Chrome debugger tools to inspect what your web page is doing, how long it takes between the initial request and your first paint. Is there anything that you can move down from there? All that stuff will apply on device as well. And then, as I said earlier, the skill endpoint can stand in for some tasks that you normally have set up an API for, right? So you might want to have a persistent store away from your device that you'd normally do some kind of session storage and a cookie. And then you'd have some way of like uploading, putting data, and getting data back from your service. As long as it's not too big, you can totally just shuttle that stuff backwards and forwards using the Alexa API, and that gives you free auth. So you don't have to worry about authorization there. And that means that your static website can be significantly simpler. Next slide.
That is a really nice pro.
Yeah, it is. It is.
Pro tips.
Yep. If you're already going to have an endpoint, you might as well make it do work.
Yeah.
And so here we are in debugging. On debugging, the Chrome Inspector on desktop, again, great stuff. That'll give you most of the information you need, and it'll give you automatically stuff like what is my CSS doing, like what order are my DOM elements in, did I have any errors in logic in setting up any of that stuff, especially when you're doing it dynamically, right? All that stuff you should be able to debug on your PC. The Fire TV, as we said earlier, allows ADB connections. That is super cool. There's a doc on the developer portal that explains how to enable ADB for your Fire TV. I would definitely recommend doing that because that will be your mechanism for debugging your communication with Alexa. So you'll want to run your skill on a Fire TV, have the Fire TV do logging and everything as normal. You hook up ADB onto your device, and then the Chrome inspector from your PC can see the contents of the web page on your device, and that is super, super handy.
Yeah, and I would even say vital. Like if you had just one device to pick to use to debug with, what would you choose, Chris?
I mean, I do the Fire TV because that gives you all the functionality. I would highly recommend that you have at least 2 devices, and that would probably be the Echo Show 8 and a Fire TV, because with a Fire TV, you won't have touch. So if you want to do anything on touch, you're going to need at least one other device.
Okay, that's a really good point. Greg Wire asks, is the Alexa Web API still invite only? Yes, it is, but I will post a link to sign up right now.
Great. Chris, I wanted to add something to this, or maybe I don't know if you were planning on talking about this later, but you can, since you have access to the Chrome inspector for debugging, that also means in performance that you can use it to profile your application, right?
Yeah, you can see a couple of basic metrics from the Chrome inspector to really understand what your application is doing. If it's CPU bound, you're going to want to inject timings and figure out, try and like get a macro overview of what's going on. The Chrome profiler can help you, but it can be a little bit dense to sift through all that data. And then if you're GPU bound in some way, then that's again up to you to sort of like binary search through your operations to figure out which one's taking the most amount of time. Unfortunately, Chrome debugger does not have a GPU breakdown, but you should be able to do the sort of traditional stuff of turning off half of your items and figuring out which rapture half is bad, and then like binary searching down to see if there's any operation you're doing that is not GPU friendly.
Yeah. Thank you.
Yeah, and we do.
I see a question from Lord of Sound.
Yeah.
There, I just noticed in the corner mentioning that caching on device can be very sticky.
Oh yeah.
Caching on the web API is going to be exactly the same as web browser caching anywhere. So you can set the headers to the cache expiry headers to behave the way you want them to, right? So I highly recommend that you have a production site that has the optimal cache headers that save you the serving the same file over and over again. So you want like the long cache expiry headers over there. Ideally, you've done some kind of hashing on the file name so that you can do permanent caching. But then while you're developing, I would deploy to a separate skill, set all the cache expiry headers to immediate, and that way you'll disable any caching on device. That's the safest, easiest way to make sure that you're looking at the newest material always while you're developing.
Cool. And then we do have a comment here that asking how long for sign up. If you're having trouble with sign up, feel free to ping me in Twitch and I'll follow up. Ping me your email address you used to sign up with. But yeah.
And then just to close out this this slide that we're on right now, you don't forget that you can always stick debug overlays on screen. It's super handy just to stick another DOM element on top of whatever it is you're doing, set it to position absolute, set it z-index in front of everyone, and then just log stuff to it. This is useful for like single time logs, like this happened, but even more useful for these are the current values of what's going on. So if you're doing animations, you can track the time, and so on and so on. So making yourself like a little debug heads up display can be super invaluable to figure out what's going on.
Yeah.
Next thing here. Yeah, the next thing here is don't forget that the device when you're loading your thing on the device, it's just a web connection. It's so you can return from your skill the local IP address of your computer, and it will just load the website off your computer, assuming you don't have any firewalls or anything that will prevent that from happening. you can just serve the web page off of your computer directly to your Echo device, and that gives you local super fast iteration. If you do a little bit, if you get a little fancier than that, in one of our experiments here, I've set up a socket connection between between the web page and my computer, and I've been able to send data to the Echo device, the page running, and like refresh images on the fly, refresh models and materials and sounds and things like that, which is letting me iterate on the art and see the results on the device very quickly. So that takes a little bit of investment to set up all that up and in a manner that you're comfortable with. But it is super worth it if you're doing a large project.
That's a really awesome tip right there. I had no idea about that.
Yeah.
We still have secrets, man. We still have secrets.
And in that same vein, Chris, then if worst comes to worst, someone could use something like ngrok or something like that, right, to do a reverse
totally. Yeah, and then you could no IP yourself back to your machine. You could there's a whole bunch of different things you could do, but getting yourself to where you're serving your website directly to your device is a huge time saver.
And of course, that brings up the fact that you can use WebSockets.
Yeah, absolutely. Yeah, in fact, WebSockets are a go, and that means a server somewhere. But you can also WebRTC.
Yes.
We've had successful experimentation with connecting multiple devices with WebRTC, both Echo devices to each other and Echo devices to any other browser, which is a wide open space of weirdness. And then finally, I think the last bit on this slide is you can always remember you've got the connection to the cloud via the skill. You're probably already debugging your skill in CloudWatch or something similar. So don't forget that if you want to send yourself events from the device, you can always just send yourself a message to just please log this for me into my logs. And that's a good way to get like an event stream that you can look back on after the skill is completed, the same way that you normally would for your endpoint.
Okay, no need to pop up a bunch of console dialogues on your web app.
Yep, their choices. And then so this next bit, here I want to talk about where do you now put your skill logic? So you've got two applications basically running asynchronously from each other, right? You've got your skill endpoint, which is a request response kind of thing, and you've got your device code, which is a real-time, whatever, iterative processing thing. So the question is, where do you put your skill logic? Well, there's two thoughts on this primarily. You've got the skill authoritative side where you write the skill as you normally would have before, and your device is basically a dumb presenter, and you send it the move on to the next slide command, basically. However complicated your presentation might be, like play an animation or change a color or do something like that. The HTML is dumb in the sense that it doesn't know where it is in the skill. All of the memory for where you are in the skill and what happens next sits with the skill. And the pros for that are that's the same code you would have been writing anyway for headless. And on the skill side, if you've already got persistence, then you're already persisting that state. So it makes it easier to stomach the whole skills are pretty transient things. The user might exit or leave or stop or leave whenever they want to. Your HTML application will disappear. It doesn't matter if all your state's already chilling in the skill. The next time you launch, you can revive the HTML page right where you left off, right? So it makes the transients a little easier to deal with. Now, vice versa, there's the HTML authoritative type of skill. This is where you're running your skill, your logic entirely on the HTML side, and your skill is basically just forwarding intents. Your skill has no clue where you are in the flow of things. It has no idea about state. It's just forwarding things as if it was just a voice controller. Now, this makes sense only if your game actually is a simulation over time. Like you actually want to tick traditional game frames and you want to do some calculation every n milliseconds to move things around or simulate numbers changing in some way, either because you're representing something physical or something metaphysical, like money changing over time or something like that. Then you want some of that information. You want that game to be running on the HTML. The pros of that obviously are you get that much more compute power. It's sitting on the device. You get a tick as often as you like it. The downside is your state is now on the device, and then you do have to deal with that ephemeral nature of skills. So you're going to have to figure out how to serialize enough information from your skill on your HTML back to your skill so that when your skill is relaunched, you haven't lost the player's entire state. So there's a little trade-off there. You can figure out some kind of hybrid between the two if you're fancy, where you maintain like large state changes on the skill side. So you remember enough about what's going on in the game. Skill's pretty aware of what's going on, but anything that requires real-time ticking happens on the device. Now, this might be super applicable to, say, like a game show, where it's super easy to remember whose turn it is on the skill side. It's super easy to remember like which question we asked last, that kind of stuff. But on the device side, you can do things like animate a countdown, and then you can synchronize the ending of that countdown with the next phase of the skill really well, because you know exactly what time it is, right? So you effectively set your own timer in the HTML page, or rather, if we go from the beginning, you're running your skill gets to the point where it's asking a question, it sends the web page, hey, start the timer for me, please. The timer goes like, sure, start the timer. And at the end of the timer, it sends a call back to the skill saying like, timer was completed. So that way you kind of split the logic between the two. They're both handling what they're good at. If your skill quit, the skill would still know what was going on if you try to relaunch. That's probably the best outcome, but it's super design specific. Like you're gonna have to work out for each one of your skills which one is applicable.
Okay. And then there's a lot of different options for graphics here.
Yes. So this is just a super high level overview of what you can do with graphics now that you're in HTML. Obviously, you can just do HTML document DOM plus usual CSS and JavaScript. That is super familiar to a lot of people. It is not super great performance, especially with a lot of animating, moving things. There's a lot of properties that if you animate will slow everything down. You probably want to, if you're doing sprite style animation where you're like moving a thing on screen, you want to make sure that you're only using CSS transforms and not animating things like the left and the top position. Certainly never change widths and heights. But the big pro here is that it is easy to do. If your skill does not require a lot of animation, there's really no reason to do anything but this. And it allows for super easy text handling. Like all your internationalization will make sense. You load fonts as normal. Like text is just super, super, super easy. Next step down is Canvas 2D. Canvas 2D gives you more options for things you can draw. It gives you a reasonable vector library, so you can do things. So you can do procedural shapes and things that fit whatever you're doing more easily, as opposed to trying to line up images and such. It does have reasonable performance, although it's pretty easy to bog it down as well, and it still has pretty reasonably good text. As in you can use normal fonts, and it will rasterize them for you. You also get access to some filters, which is nice. So you can get like drop shadow rendering and a couple of other things from there. Now, the creme de la creme of performance is to go Canvas 3D, or as is better known, WebGL. Here you get basically direct access to the GPU. You're uploading data in the form of buffers and programs in the form of shaders directly to the GPU. They're executed there as if they were entirely native. So that gets you like as close as you can get to the rendering performance of a native application. You're still constrained by your JavaScript in that sense. Like you have to prepare those buffers and upload them. You have to modify uniforms every frame, but you're getting some pretty primo performance there. Now the downside for me is it's significantly more complicated to use. Even with a library, people do find it, if it's your first time at 3D or if it's your first time with WebGL, there is a steep learning curve to get in there. But once you do, it's great. The other downside is text is terrible. Text is basically, you're back to like the usual video game universe of there is no text. You have to deal with it yourself. There are libraries that will help you with this. What they'll do is they'll rasterize a font for you into a texture and then produce quads. All of this is doable. There's just a significantly higher learning curve to get there.
Okay. We do have a question from Goldzulu about this. How good is the GPU on the Echo Show? Or I guess across all the Echo shows.
So I think we'll chat about that a little bit later, but the short answer is it goes from lower performance to higher performance, and there's like a whole gradient that you have to design for. It is somewhat comparable to making a mobile game in the sense that you are going to target multiple devices at the same time.
Okay.
Well put.
Yeah. So we got this case study of Ticket to Ride.
Oh, I had one more thing to say on that last slide. Sorry. And I just wanted to call out that you can also play video. Video, you can play small videos, large videos. You can place them on a page. You can full screen them. And then my favorite line of experimentation right now is you can feed videos to WebGL and then run them through shaders. So you can do quite a lot of real-time like color correction, blurring, interesting sort of glitchy effects and things like that that you can do dynamically based on what the game is doing. So I'm actually kind of a fan. Maybe this is like the revival of the FMV games.
Huh. That's a really interesting idea.
But yeah, I think there's like there's scope there for experimentation. I'm currently having a lot of fun with it.
See, now I want to know what you're working on, but no need to spoil the fun.
All right then. So case study. We looked at Ticket to Ride earlier in the stream, and then Luis brought it up as well. It's coming up one more time here because I want to talk about how it relates to the things I was just talking about. So Ticket to Ride is fully skill authoritative. The logic that Days of Wonder put in there runs entirely in the skill and runs basically identically between the headless game and the HTML version. The small changes between them are that the HTML version obviously sends the directives to communicate with the HTML page, but it also uses the timing from the HTML page. So where on the headless version, you would send the usual response and then expect the microphone to open. On the HTML version, it sends the response down to the HTML and then waits for the HTML to send back, we're done presenting. And the reason for that is because the HTML has animations that go beyond the sound file, and the game wants to wait until its animations are complete before it continues on to the next thing. So that timing happens on the device side. Now that timing actually comes from the transformers as well, which you mentioned earlier. So it uses both word marks and sentence marks, which are timestamped events in the rendered MP3 that tell you where the boundaries between the words are. It also uses one more thing called a SSML tag. I think they're just called tags. And then that lets you put a named mark arbitrarily in your TTS when you're writing the text. And then this game uses that to do transitions. So it'll do stuff where it says, returns an entire long response with multiple sentences in it, like, all right then. And then it'll be a command and then after that says, show the character. And the game will interpret that to be the moment when the character should walk on the screen. So that was super, super handy there to avoid doing any kind of manual synchronization of that kind of stuff, and for keeping those things synchronized in the translated versions of the skill. So as long as the tags carry along text of the translations, all the cues for the characters coming on and off and the cards sliding on and off come from the text, which is pretty cool.
So
that's very slick.
Just to be clear here, that does not get pronounced in any way by the SSML text-to-speech engines. No. Okay.
They're hidden marks, just like punctuation.
Oh, right.
Now, it is super fun, and so the closed captioning that you see in the skill comes from the same place. So along with the demux data that Luis mentioned earlier, you get the full text for what was being said, along with those sentence marks. So we reveal and show and hide the sentences using the sentence marks, and highlight the words using the word marks. Entirely automated pipeline, super cool.
That is very cool.
Now the visuals here, Now the visuals here this is the standard HTML approach. So this is just an HTML page with DOM elements. Each one of the characters is an SVG. CSS and JavaScript used to move them around. The nice thing about SVG here was that it was resolution independent. So all the way down from the Echo Show 5 all the way up to the Fire TV, they look nice and crisp. They also use CSS filters. So they each have drop shadows there, and the drop shadows generated procedurally. Let's see now. Yep, and then we know the rest of it. The other thing worth noting here that I don't think we mentioned before, other than in passing, is that when you're doing your own audio mixing on device, because you can use web audio, the big difference between Ticket to Ride headless and Ticket to Ride in HTML, other than the visuals, is that the music is continuous. So the music carries underneath the prompts, it carries underneath the responses, and it only changes when the situation of the game changes, rather than restarting on each response. And that is just really delightful.
Yeah, it really makes it feel like a more continuous session.
Yep.
And we've got this other case study that you built, which I'm a fan of.
Would you want to run the video for me?
Let's do it.
This is one of my favorite demos.
Alexa, enhance A8. Alexa, set all asteroid rally points to B7.
Setting all asteroid rally points to B7.
Alexa, zoom all the way out.
Yes?
Send 50% of ships here.
Moving 50% to A5.
All right. We can stop now. I mean, keep it running if you like in the background, but we
Enhance
can
A5.
watch me not get destroyed after this.
The sounds are so soothing.
Beep boop 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 beep.
Alexa,
That was actually I was
send
the voice
all
actor
ships
for
to
those
A5.
sounds.
Yeah, right.
Moving 100% to A5.
So yeah, here, as opposed to Ticket to Ride, we have an example of HTML authoritative. So here we obviously have simulation going on where the ship's being ticked every frame. There are lasers being fired every frame. There's like collisions to be detected every frame, explosions to run, and all that kind of stuff. So that makes a lot more sense to run on the device side than the skill side.
Alexa, zoom out.
And this one is fully HTML authoritative. So it the
Alexa,
design for this one
send all
serializes the
ships to
current
A5.
state every now and again as a save game.
Moving 100%
So if you quit the
to
skill, you'll
A5.
like fall back to your last
Alexa,
save game, which is a
send
little bit of a
50%
bummer,
of ships
but
to
it does allow
D5.
you to be able to do a completely new kind of game.
Moving
This one's
50%
written entirely
to
in WebGL.
D5.
So in the JavaScript side, we have the logic for moving things around, and we have logic for the collision detections and the AI making choices about where to send its ships. All that's packed into a couple of vertex buffers. And then we use expansion on the GPU side
send all ships
to
from
create
D7
all of
to
the
A5.
visuals. That
Moving
includes
100%
working
from
out like line
D7 to
distances and
A5.
things on the shader to keep more of that calculation away from the CPU. That ended up being a big win on this one. I think the difference was sort of a 30% improvement in frame rate for offloading a lot of that work onto the GPU side.
Alexa, send all
This
ships
one
to
is,
escalate.
for this skill, visuals are key information as
Moving
opposed to in Ticket to
100%
Ride
to
where
escalate.
it was an equivalent experience on headless. Here, obviously, this game could not be played on headless, and I think there's been a little bit of chat
Alexa,
in the chat room
P4.
about what happens to games like this. And I think
Yeah.
it's evolving. Like we're talking about this backwards and forwards. And the comment by Laura Sound actually is just about right now.
Alexa, zoom out.
For games that are like this, that clearly don't have a voice experience, the minimum requirement is that you do have an answer
Alexa,
on a voice
send
only
all ships
device
to
that
gravity.
says, "I'm sorry, you need a screen to play this game."
Moving 100%
Ideally,
to gravity.
there could be a little bit
Send
more
all
than
ships
that.
to
Ideally,
Sunday.
you might be able to tell the user what their high
Moving
scores were, or
100%
there's some
to
interaction
Sunday.
there that makes them feel less disappointed at that moment in time, and ideally invites them to play your game later on. That's sort of like a marketing moment, right? But yeah, this whole topic is evolving. Watch this space.
Alexa, send
And I
all
think
ships
the
to
other
dangerous.
cute thing I think that happened in there is there was a
Moving
moment where I touched the
100%
screen
to dangerous.
and then I
Alexa,
issue a command. I think I
send
touched
20% of ships to
a
escalate.
cell, and then I said send 50% of the ships
Moving
here.
20% to
And I
escalate.
think that's actually a really cute new interface paradigm where the touch functioned both as push to talk and it functioned to set the context for relative references in the voice, right? So I didn't have to repeat the location verbally that I wanted the ships to go to. The touch also indicated this place or here or this cell that I would later reference in voice. And I think that's actually going to be a really, really interesting area of exploration, mixing the two things.
Right, use the different modalities in the ways that they're best. Right, clicking on that screen to try to gather up all the ships you want to send isn't really great, but saying 50% is fantastic.
Exactly. Yeah, you get to like lean on the strengths of both modalities. Picking something by pointing at it is super easy, but then verbally you can give like these big macro, longer, more complex, fuzzier commands that are super satisfying to verbalize.
Yeah.
Like there's just a wish fulfillment here of just being a ship captain saying like do stuff.
Yeah.
And then it does stuff.
And This is a topic I saw a little bit of chatter in chat about. Greg had a question related to this, but what are the security implications around the API? Uh,
Yeah. So we'll talk about this really quickly. I know that we're at the top of the hour. I don't know.
we'll extend it 10 minutes. So
Okay, that's fair. Excellent. Yeah. So basically, security. Basically, you have limited access to device components, right? There's our customers' data is. It's important that they feel that the data is both protected and they feel that it is that way too, right? So the idea here is you're not going to have direct camera access, even though you're on the web. So if you try to access the camera, it's just not going to work. You're not going to have direct audio access. So this is kind of like bad cop right now. You're not going to have audio access. All the audio is going to get done through the skill side. There's no local storage in the sense that if you use cookies, they will be cleared at the end of your session. So there's no access to like WebDB or whatever that is, and long lasting cookies, right? No redirects, so your application does need to be a single page application. You can't open new tabs or windows, and all communication must be done through HTTP and HTTPS. That said, there's still a lot that you can do. So, did we have a? I wanted to talk about performance before we go.
Yeah.
Did we have a slide for that? Should be the next slide, right?
We've got certification and Q&A.
Okay, so I think that might have gotten dropped, but I'm just going to revisit performance really quickly too. So you have we need how do I phrase this? There are other processes running on the device other than your game. And so as a developer, you need to be mindful about resource consumption. If you start resource hogging, your application will be killed. So that's just something to be aware of. Somebody brought up a great question about performance across different devices.
Mm-hmm.
Devices can vary, and so the best thing that you can do is you take the same approach as you would for developing a mobile game. You do some performance check across devices in different states and try to get a baseline for how your game behaves across those devices, and that is the best advice I can give you right now.
And on that topic, there are a couple additional certification requirements for Web API skills.
Yes, so you must label your skill as a game, otherwise it will fail cert. I think that's the biggest one, and there should be a way to do that either in the developer console, but you can always it'll be. That information will be available to you in the docs. And the other thing is that once you've certified and published your game and it's live, and you need to update your game, it's the same restrictions that apply to the skill. So you can basically just update your game as you need to.
All right, so we got 5 minutes for questions here. I saw one question up higher about local multiplayer games and people shouting over each other. So does this help at all with that?
Nothing specifically here helps that isn't the usual thing you should do, which is make sure that if you have local multiplayer and it's turn-based and people know they need to be taking it, then you need them to be taking turns, then make sure that you onboard them sufficiently and that you have really clear markers for, hey, it's a turn is happening right now. Everyone pay attention. It's always good to announce that with audio, like a really clear, very recognizable moment. It's always good to sort of foreshadow it too, right? Like make sure that if you have like a celebration audio, you don't just immediately play the bing, it's your turn now, but like fade it out first and then like bing, and make sure that you lead people into the next turn. You have to give them enough warning that if they're smack talking each other, the person whose turn it's about to be, who would lose out if everyone was talking, smacks everyone else upside the head and says, "Shut up, it's my turn."
Sorry, I actually think I misunderstood Goldzulu's question. I apologize, Goldzulu. Multiplayer across multiple echo shows, that is, with people trying to change the same state. So I believe the example was, saying one person saying right, other person saying left for some character on the screen.
Sure. So I've been building a couple experiments around that kind of thing. using a normal bounce server, I've been able to get WebRTC connection open between two different Echo Show devices. At that point, everything becomes traditional video game programming. So all of my experiments so far have been peer-to-peer connections with a nominated authority. So one of the players becomes nominated as the authority. Everyone else is basically sending inputs to that device, and that device chooses how to resolve those things.
All right. Any other questions? Anyone in chat building awesome things with Web API right now? I know Lord of Sound you are. Anyone else?
Yeah, thanks for trying out the API, by the way, Lord of Sound. It's lots. I haven't been able to like respond to everything in chat, but I'm like reading everything. Great suggestions.
It's very exciting.
So, Goldzulu is wondering how similar it is to Google's Interactive Canvas. I'm not familiar with Google's Interactive Canvas API.
Me neither. I couldn't speak to it.
Yeah.
So.
Yep.
If there is functionality you would like here, Goldzulu, that we are not covering currently in Web API, go bug their teams. You now know.
And vice versa.
Here, I'll put the Twitters back up on the screen. There. Oh.
Wonderful.
Oh, actually, Lord of Sound. That reminds me. That Galaxy Tactics prototype. I built that in 3. I used that as sort of like a shim to get to WebGL. It's all custom shaders and stuff, but 3 is still awesome.
So, I guess closing remarks. What suggestions do you have? Like, what would be your top tip for developers getting started with this API? Chris, to you first.
I don't know if I've got a top tip. I have wishes. Like I welcome all software, obviously, on our devices. I think any development is fantastic. But the stuff that makes me the happiest is the stuff that explores the boundaries, right? That tiny little the demo that I built there. The fact is that obviously could have been just a normal RTS game, and there's plenty of games that are sort of similar to that. But the thing that I was exploring there was the sort of wish fulfillment of verbally asking for these things to happen, and then trying to figure out how fuzzy I could be as a player, and how smart I could make the device appear to be, as if I had, like a really great first lieutenant who was like executing all my shit, even though I wasn't really saying it really clearly. And that was kind of the area exploration that was driving me while I was doing that. That's what made me happy when I made something that felt like, oh well, that is a good reaction to that sentence. It looks like nobody would be mad that the game reacted that way. And in fact, maybe they'd be delighted that they were like, oh my God, we're all dying, and then the ships all scatter. Is actually a perfectly valid command for a captain to give. So the things I think I want to see in the world, if anybody's listening, are things like that. Things like exploring why connecting voice to a screen that gives you a lot of data is interesting.
Very cool.
Yeah, I'm excited to see those as well.
Yeah. I think my take on that question is like, what would I want to? What would be my like tip for people? Go experiment. I am very excited to see what you're going to do, and I want to see what can be done. I want to know about what can't be done. Right? Like, it's really, really inspiring when and motivating when you see someone build something on a platform that you've been dedicating your not platform technology that you've been dedicating your time to, and it's always delighting when you see a developer do something you thought like, wow, I would have never thought to do that, or someone come and say, hey, why can't I do XYZ? I'm trying to do this thing, and you're like, oh, well, I just didn't know, right? So lots of experimentation. I want to see like what kind of experiences people want to build, like what are they trying to do, like what can't you do, and like what should we be enabling, right? So experiment, and find out where the walls are, and then tell us about it.
Very cool. So you heard it from them. Tell us what you're doing. Tell us what you can't do and want to be able to do. And thanks for coming to all of these game streams. Thank you, Chris and Luis, for joining here and sharing your knowledge.
Yeah, thank you for having us.
See you all
Thank you for having us.
another
Yep.
time. Bye.
Awesome. Bye, everyone.